This is Learning Assessment Problem 3-4. In this problem, we are requested to determine the values of the two indicated node voltages V1 and V2 with respect to the indicated reference point. The circuit has a dependent current source which has an amplitude of 2 times I sub O, and I sub O is the current shown flowing downward through the 10K resistor at the left side of the circuit. So our auxiliary equation for I.O. will be V1 divided by the 10K. So this will, in order to proceed with the nodal analysis, we'll want to sum currents at each of the two node voltage nodes using Kirchhoff's current law. So we'll indicate those currents as flowing away from the node and proceed with our KCL approach. So if we do KCL at the node V1, we will have the currents V1 divided by 10K minus 4 milliamps plus V1 minus V2 divided by 10K is equal to 0. Rearranging terms, we have V1 times the sum of 1 over 10K plus 1 over 10K minus V2 divided by 10K is equal to 4 milliamps. Or evaluating this, or condensing this, we have V1 or rewriting, we have 1 over 5K V1 minus 1 over 10K V2 is equal to 4 milliamps. This is one of our node equations. Similarly, if we do KCL at the node voltage V2, we will have V2 minus V1 divided by 10K plus 2I0 for the dependent source plus V2 divided by 10K is equal to 0. Now we can, at this point, substitute the value that we determined for I0 into this expression and rewrite this as V2 over 10K minus V1 over 10K plus 2V1 over 10K. That is the term due to that dependent current source. Plus V2 over 10K is equal to 0. Or condensing this, we have minus 1 over 10K V1 plus 1 over 5K V2 is equal to 0. And that is our second node voltage equation. We've rewritten those two equations here at the top of the page. We'll use the matrix format approach to solution of the two node voltages. So we can write down our conductance matrix, 0.2 K to the minus 1 minus 0.1 K to the minus 1 minus 0.1 K to the minus 1 and 0.2 K to the minus 1 times the voltage matrix V1 and V2 is equal to the currents 4 milliamps and 0. So this represents the first row across as our equation 1 and the second row of terms is our equation 2. If we solve this, we obtain the node voltages V1 is equal to 16 volts and V2 is equal to -8 volts.